So pop quiz 2, which is related to unit 1 and 2 topics. The first question is related to the material. The compressive stress and strain graph is there for one metal as shown. Show that the Young's modulus is 2 exponent 11. For a stress and strain graph, if we need the Young's modulus is actually equals to the gradient. Young's modulus is denoted by E, which is actually the gradient of stress and strain graph. So you can take any 2 points. The first point on x-axis you will take as x1. The second point on x-axis you will take that as x2. The second point you will take as x2. And as I mentioned, whenever you use the values, like in the calculation, don't forget to use these scientific notation. Say this is 0.25, so it is not only 0.25, it will be 0.25 into 10 to the power minus 3. And same way, 1.6, 7, 8, and 9. So x2 is not only 1.9, it will be 1.9 into 10 to the power minus 3. The first point on y-axis, that is y1, which is like 1, 2, 3, 4, 5 boxes are there. So which is 0.5, but we don't say only 0.5 because exponent 8 is there. So y1 is equals to 0.5 into 10 to the power 8. And y2, so that will be equals to 4.0 into 10 to the power 8. So when you use a formula for gradient y2 minus y1 over x2 minus x1, so y2 is 4 into 10 to the power 8, y1 is 0.5 into 10 to the power 8, x2 is 1.9 into 10 to the power minus 3, and x1 is 0.25 into 10 to the power minus 3. So when you divide, you will get the exponent and the number which is in the range of 2 exponent 11. So stress and strain graph, the gradient represent, if stress is on y-axis and strain on x-axis, the gradient represent the Young's modulus. The metal part must not compress more than 0.6 millimeter. So the change cannot be more than 0.6. When the force is 9.5 exponent 5 is applied. Deduce whether this metal is suitable for the part. So we have to, like, the change in the length cannot exceed more than 0.6 millimeters. So we have the formula, the Young's modulus is equals to stress over strain. So first, we will work out the strain from this. So strain will be equals to stress divided by the Young's modulus. What is the stress? Stress is force acting on unit area. And what about the Young's modulus? That is our gradient from the previous part. So the force which is applied 9.5 into 10 to the power 5 Newton divided by the cross-sectional area. If it was in millimeter or centimeter square, you have to convert into meter square. So every time, whenever you see the question, unit conversion is the most important part. So force divided by area divided by the Young's modulus, which is 2 into 10 to the power 11. If you get your answer in the previous one, you will use that answer. So this will give us the how much strain is there. And after finding the strain, because this is giving us the strain, how much strain is there, and after working out the strain, so say the strain when we work out from this one, it is 9.42 into 10 to the power minus 4. That's a strain. And then we know strain is equals to change in length over original length. So if we need the change in length, so epsilon multiplied by, like, the strain multiplied by the original length, the strain is 9.42 into 10 to the power minus 4 multiplied by the original length, that is 0.84. So 0.84. When we multiply, that will give us the change in the length. And the answer will be in meters. So it will be like 7.9 into 10 to the power minus 4 meter. If you want to convert into millimeter, like meter to millimeter, we multiply by 1000. So if you multiply by 1000, this will become 0.79 millimeter, this value. So it means the change in the length is 0.79, but they mentioned the metal must not compress more than 0.6 millimeter. But here, in this case, the metal will compress more than 0.6 millimeters. So means this metal is not suitable. So it's not suitable. Why? Because the reduce in size or the decrease in size for the metal is greater than what we want. Like we want it only not to compress more than 0.6, but it is compressing or changing length 0.79 or about 0.8 millimeter, which is more than 0.6. So this metal is not suitable for the purpose. The next question is related to circuits. A student set up the circuit to investigate the properties of a negative temperature coefficient thermistor. Negative temperature coefficient means like if we increase the temperature, its resistance decreases. The power supply has a negligible internal resistance. Show that the voltmeter reading is about 6 and the ammeter is 3 milliamps. So how we can work out this? There are different ways to do this question. One, you can use a potential divider formula. That is one way. Another one, you can work out the total resistance, and then from that you can work out the resistance of that part and then use the potential divider formula. Or you can also work out the combined, because the current is 23 milliampere. So this 23 milliampere will flow through the combined, both of them. So if we work out the combined resistance of these two, and we know the total current together is 23 milliampere, so we can work out what is the voltage. So first, what about the combined resistance of these two? When two resistors are in parallel, you can use a product divided by sum, but it's not valid for 3, it's only valid for 2. So product will be 500 so it will be product divided by sum. So product will be there in numerator and sum in denominator. So 500 into 600 divided by 500 plus 600. And that will give us the combined resistance 272.7. Okay. So the combined resistance is 272.7 ohms. And we know the total current is 23 milliampere. So we can work out the voltage V equals IR. So 23 milliampere means 23 into 10 to the power minus 3. And the combined resistance is 272.7. So when you multiply, you get 6.27 volts. So which is about 6. The question is related to work, energy, and power. In the game called The High Striker, a person hits a button with a hammer. This causes the cylinder to move towards the bell at the top as shown. The hammerhead, which is initially at rest, at the highest point, as a person moves the hammer, so person strike, hit the button, the average resultant force on the hammer is 58 Newton. The hammerhead moves at a distance of 1.2 meter, like this is the height which it moves before hitting the button. The cylinder moves 2.7 meter up, like this is a movement of a cylinder. Deduce whether the cylinder hits the bell, and the efficiency of the energy is only 4%, and the mass of a cylinder is 0.15. So two things are there. First, you have to identify like what are the forms of energy here in this case. So, and the efficiency is only the cylinder must move 2.7 meter up to hit the bell. So this is the distance which the cylinder should move. And this is only hitting it, its efficiency, energy transfer is only 4% into useful. So first, there is a work done, like there's a work done on the hammer by the person, and that work done has converted into GP, gravitational potential energy. So if you use a formula for efficiency, the efficiency is a useful output. So useful output will be gravitational potential energy plus the input energy, which is a work done to move the hammer, like applying force and moving it to a distance of 1.2 into 100. So first we'll work out GP. We have the efficiency. We will get the work done because we know the force and the distance we move. So we'll work out GP. And then after finding GP, potential energy is mgh. So we have the mass, we have the gravity, so we can work out the height which it will move. So first, how much work is done on the hammer head? That is the work done is a product of force and distance. The force is 58 and it is 1.2. So this will give us 69.6 joules. That is a work done. Then we have efficiency formula. Efficiency is the gravitational potential divided by work done into 100. Efficiency is for only 4%. Gravitational potential energy we don't know. The work done is 69.6 into 100. So you simplify and find the GPE or gravitational potential energy. So 4% of this will be about 2.78 joules. So GPE or gravitational potential energy is 2.78. After finding gravitational potential energy, after we work out the gravitational potential energy, what we'll do? The gravitational potential energy is mgh. So 2.78, the mass of this cylinder, which is 0.15. The gravity is 9.81 multiplied by height, which we are finding. So when we work out the height, this will be about 1.89 meter. So 1.89 meter, that is less than 2.7. So this will not hit the bell, because to hit the bell, it must travel 2.7. Same thing about this question. What if they also give you the mass of the hammerhead? Okay. If the mass of the hammerhead was also given, then what will be the total useful, like input work done? So in that case, the total energy used, that will be equals to the work done plus the gravitational potential energy of this hammerhead. Like work done will be force into distance plus mgh, the mass of the hammerhead, into gravity into height which we move, like we move to a height of 1.2. That will give us a total. Actually, it should be like this, but in the question, because it did not give us a mass of the hammerhead, that's why we ignored the gravitational potential. Because what will happen, like as a person hitting this button, so the hammer is at certain height, so hammer is also having GPE, and then he's also applying a force on the hammer to hit the button. So it's the gravitational potential energy plus the work done will be equals to the total input energy. But why we did not use that in our calculation? Because the mass of the hammerhead was not given. So in practical, more energy will be input as compared to what we calculated here. Is it clear, this question? This question is related to light. The irrigation system uses a pump to move the water from a lower level to a higher level. The electricity for a pump is generated using a panel, the solar panels, solar cells. The solar cell is 1.2 meter long and 0.8 meter wide. To pump the water from a lower level to a higher level, it needs about 140 watts. Calculate the minimum efficiency of the panel of a solar cell that will operate the pump. The intensity of the light is 1040 watt per meter square. So this there's an input power is there, like intensity is 1040. On what area? This is 1.2 meter and 0.8 meter. And that produce electricity because the input energy is a light energy and the output is electrical energy, and that electrical energy is used to operate a pump, and that pump is lifting the water for irrigation from the well. So we have the intensity and we have the area. So we have the formula: intensity or a flux is power per unit area. So power will be intensity multiplied by area. So intensity is 1040. The cross-sectional area of the panel 1.2 into 0.8. And what is our assumption here? Our assumption is light is perpendicular, because if it was if it was making certain angle, then the component which is perpendicular will have a different value, like lower than what we calculated. So this will give us the power which is input 998 watt. And our assumption is that like this all energy is being absorbed and there is no reflected. Then the efficiency is a useful output divided by total input times 100. The useful output is what? Because it is used to operate a pump which need 140 watts. So useful, we want one, like minimum we need 140 watts. And input is 998 into 100. So this will give us the efficiency of this, about 14% efficient, this solar cell. Like we need a solar cell which is with this dimensions, it should be 14% efficient to lift the water upward. Discussion is related to the fluid. An object of mass 35 kg fell from a boat to a seabed. The object reached a terminal velocity. So if an object is falling through a fluid and it reaches a terminal velocity, so what will the free body force diagram? The weight will act downward. There will be, if you look, when we draw free body force diagram, the length of the arrow shows the magnitude of the force. So there will be upward and downward forces should be equal. So when you draw the arrows, if the downward arrow is like 3 centimeter in length, the upward arrow should also be 3 centimeter. But the upward forces will be the up thrust and the viscous drag. So one of them will be the up thrust and one will be viscous drag. But the total length of the upward arrow must be equal to downward as it is moving with the terminal velocity. Show that the drag force of the object at a terminal velocity. So if it is moving at a terminal velocity, what we can say, the equation we can write, weight is equals to up thrust plus the drag force. So we want the drag force, so it means the drag force will be equals to weight minus the up thrust. What about the weight? Weight is mass into gravity, and up thrust is density of the fluid, volume of object, and gravity. That's how we work out the up thrust. Like the drag force. So mass of an object, a 35 kg, so this will be 35. the gravity is 9.81 minus the density of the fluid. The density of the seawater is 1030 or 1.03 into 10 power 3 kg per meter cube, multiplied by volume of object is already given, 1.6 into 10 power minus 2, multiplied by gravity 9.81. So this will give us the drag force on this object. So it will be around 181. Why we take a density, whenever we work out the upthrust, why we take always the density, because the formula for upthrust is always the density of fluid, volume of object and gravity. But what is the reason for that? Look, what is the concept of upthrust? Upthrust is actually the weight of the liquid displaced. So when we immerse an object like this is an object, we immerse this object in a liquid, the liquid will come out. How much liquid will come out? What is the weight of the liquid move out or displace? That is equals to upthrust. So, and what is weight? Weight is mass into gravity. So upthrust is mass of a liquid displaced multiplied by gravity of a liquid displaced. Gravity of the gravity. And what about the mass of a liquid displaced? Mass is density into volume into gravity. So density of a liquid or a fluid, volume of a fluid and gravity. But this is not the total volume of the fluid. This is the volume of the fluid displaced by the object. And volume of the fluid displaced by the object is same as the volume of the object. That's why the upthrust is equals to density of the fluid, volume of object and gravity. So how much liquid displaced by the object, that weight of the liquid displaced is actually equals to upthrust. Is it clear? This question is related to polarization. Light from the sun arrives on a solar cell is unpolarized. Explain the difference between unpolarized and polarized light. You have to memorize this answer. You have to learn this, the difference between the polarized and unpolarized light. Unpolarized light has oscillation or vibration in many planes. Look, there are two definitions. If you use the first definition, that the unpolarized light has the oscillation or vibration, you use any term, in all planes. If you use the term plane, because if you use the term direction, there will be different definition. So unpolarized light has oscillation or vibration in all the planes, and the polarized light has oscillation or vibration in one plane. Then what is the third mark for that? Which include the direction of travel. So if you use the term plane, you should mention which include the direction of the travel. This is a definition in terms of the plane. Like if you write your definition in terms of the plane, this will be the answer. But what if you write the same definition in terms of direction? Like we want to write the polarized and unpolarized light, the definition in terms of direction. So we will mention the unpolarized light has oscillation or vibration in many, like in all directions. This has only one direction. And when you mention about direction, which is perpendicular to the direction of travel. So if you use the term direction, then you should mention it is perpendicular. But if you use the term plane, the plane include the direction of travel. So either write this one, the plane one, or the direction one. Though you cannot combine these two, because plane means like the whole axis is involved. So when we say a polarized light, the polarized light and unpolarized light, if we use the term plane, it includes the direction of travel. But if you use the term direction only, like vibration in all the direction, so in that case, the direction is perpendicular to direct, or a vibration or direction is perpendicular to direction of travel. So any one of them, you cannot write both at the same time. It won't be correct. Describe how student can demonstrate that this light from a sun is unpolarized. So the light which is coming from the sun, how student can demonstrate that this light is unpolarized light. Means it has multiple direction of vibration. So what student can do, he can place pass the light through a polarizing filter. So intensity of the light will decrease. But when he rotate the polarizing filter, the intensity of the light will not, like, it will remain same. The component which is passing from the component of a light which is passing, that will change. Like first it was vertical polarized, so vertical component will pass. Then it is horizontal polarized, a horizontal component will pass. But the intensity of these two lights, it will be dim as compared to the original light from the sun. So originally, when we place a polarizing filter, the intensity of a light will decrease. That is one thing. But when we rotate the polarizing filter, because every time there is a component passing from that component of the light from sun, so as a result, there will be no more change in the intensity of a light. So we can identify that this light is a unpolarized light. But what if it was a polarized light? Then what will happen? Like if it was a polarized light first, when we place the polarizing filter, there's a light. But when we rotate the polarizing filter, and if the plane of this polarizing filter are perpendicular to the component, then there will be no light. So if it was a polarized light, then at certain angle, we will observe the light, and we rotate 90 degree, there will be no light. But if it is an unpolarized light, so unpolarized light, when we observe through polarizing filter, first it will reduce the intensity because most of the component are being absorbed. But when we rotate the polarizing filter, there will be no change in the intensity of light. This question is about momentum. A slow moving asteroid was hit by a fast asteroid B, and they are absorbed, like move together. Show that the mass of asteroid A is about. So use the conservation of the momentum. The momentum before is equals to momentum after. So before the collision, the sum of the momentum before, that will be equals to sum of momentum after. So A is having a momentum of 2.19 into 10 to the power 3. Before a slow moving asteroid A was hit by a fast moving asteroid B, and asteroid B is absorbed in A. And before the collision, it has, velocity is given and a momentum of this. Okay. So that the mass of asteroid, so we just need the mass instead of using, like we have the velocity and we have the momentum, just need the mass. So momentum is m into v. So we have momentum here 1.8 into 10 to the power 17. M we don't know, and the v, the speed is 2.19 into 10 to the power 3. So we can just, this will go there in division. We'll get the mass of this asteroid. A pulse echo technique question. Rolled steel joists, sorry, which are used in construction of building as shown. The strength of RSJ is greatly reduced if there is an air gap within the steel. Ultrasound is used to detect an air gap in RSJ. The pulse of ultrasound are sent by a transducer into an RSJ, and any returning ultrasound is detected in the transducer. Explain how arrangement can be used to show whether the RSJ contain an air gap. So how we can identify that it contain an air gap? And a 4-mark question, a theoretical. So first we'll send ultrasound pulse is there, and that ultrasound pulse will strike if there's an air gap, like it will strike and bounce back, and we calculate the distance between. So speed of a sound, like example, speed of ultrasound in the steel is known. So we'll record using a transducer. First, we'll produce a pulse. That pulse will be sent, and if it will bounce back. To know whether there's an air gap or no, so we'll use a formula. Speed is 2d over t. So speed is known, and time we record by using this transducer. So speed multiplied by time divided by 2 will give us the distance. So this distance d we compare with the thickness. If this distance d and the thickness are same, it means there is no air gap. Because if there's an air gap, like if for example, if the transducer is placed at this position, if the transducer is placed at this position, there is no air gap. So the pulse will strike, and it will, like we'll use a pulse, we send and reflect it and calculate the time it takes. And using the speed and the time, we work out the distance. So in that case, the distance which we calculate will be equal to the thickness. So means there is no air gap. But if the thickness is not equal to the distance which we calculate, it means there is a air gap. So using an ultrasound pulse, which bounce off or partially bounce off, you can mention, we record the time it takes to bounce, like return, and using a speed and the time, we determine the distance, and we compare that distance with the thickness. If that distance is, if the thickness is more and the distance is less, it means there's an air gap. But if they are equal, it means there is no air gap. Is it clear, this one? How the pulse echo can be used to determine the thickness?